Hi, I'm Bob. Welcome back to 5 Minute Econometrics, a tutorial for econometric learners. Today, we will talk about the confidence intervals. The most familiar interval is the estimate interval. After we regress a model, we obtain a point estimate of the coefficient. We call it beta hat. We can construct the confidence interval of the estimate. That is a range of likely values for the population parameter. We call it the interval estimate or the estimate interval. The upper and lower bounds can be computed using the point estimate, the critical value of the level of confidence, and the standard error of the estimate. For example, the 95% confidence interval for beta hat in a large sample is given by from beta hat minus 1.96 times the standard error of beta hat to beta hat plus 1.96 times the standard error. In addition to the estimate intervals, we can compute the confidence intervals for predictions. A prediction is a predicted outcome from the estimate model, using the OLS estimates we obtain and the particular values of the explanatory variables. There are two types of predictions. One is the average prediction, and the other is the individual prediction. The average prediction is the predicted value of the outcome variable if the explanatory variables take some particular values. It is an expected prediction in the sense of the average. It represents a typical or average person. The variance of the prediction comes from the coefficient estimates, and the variance of the error term has been smoothed out. By contrast, the individual prediction focuses on a single person's particular outcome. It has the same value as the average prediction, but a wider standard error to account for both the uncertainty in the OLS estimates and the error term. The error term contains unobserved factors that affect the outcome. The variance of the error term for a single individual outcome will not be averaged out. Therefore, the variance of the individual prediction is larger than that of the average prediction. Since the standard errors are based on the variance estimates, the individual prediction interval must be wider than the average prediction interval for the same model. There are two ways to find the confidence interval for the average prediction. We use a simple regression model to show it. The original model is y equals beta 0 plus beta 1 times x1 plus mu. Suppose we want to find the average prediction theta 0 and its standard error when x1 equals c1. The first method is to form a new variable, x1 minus c1. We regress y on the new variable. The average prediction theta 0 and its standard error can be obtained from the intercept. The second method is to use Stata's margins command after the original regression. For example, here's the model relating house prices to the size of the lot, the size of the house, and the number of bedrooms. The question is to find the expected price for a house whose lot size is 10,000 square feet. House size is 2.3 thousand square feet, and the number of bedrooms is 4. To calculate the average prediction, we construct 3 new variables, x1, x2, and x3, which are lot size minus 10,000, square feet minus 2.3 thousand, and bedrooms minus 4, respectively. Then we regress the house price on the 3 new variables. The intercept estimate is the predicted price, $337,000. The standard error for the prediction is 7.37. The 95% confidence interval for the average prediction is from $322,000 to $351,000. Another way is to type the margins command in Stata after the original regression. Putting all the evaluation values in the parentheses after the add option, we can find the same average predicted price along with its 95% confidence interval. For the individual prediction interval, we need to use the following formula for its standard error. It considers both the variances of the OLS estimates and the error term. The first part is the variance of the average prediction, and the second part is the variance of the error term. In our example, if an owner of the house with the above characteristics is going to sell her house, what is the prediction interval for the selling price? For a single case, we apply the individual prediction interval. From the original regression's result window, we can find the estimated error variance, sigma squared hat, 3,580. We have already obtained the standard error for the average prediction, 7.37. So we can calculate the standard error for the individual prediction using the formula. It is 60, much larger than the average prediction standard error. The error variance, sigma square hat, contributes much to this standard error. Then we can construct the 95% confidence interval. It is from $219 to $455. Compared to the average prediction interval, the individual prediction interval has a much wider range. Today, we discussed the prediction intervals. We must distinguish between the prediction intervals for the average person and for a single particular individual. The individual prediction intervals are always wider than the average prediction intervals for the same model. Thank you so much for watching this video. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.